Find the domain and range of the following relation. Let's begin with the first one. So here we have a relation R, which is defined as the set of ordered pairs A comma B such that A belongs to N. N is the set of natural number. Here A is going to be less than 5 and B is going to be equals to 4. Okay, fine. So here we have A less than 5 and A is a natural number. So what are the possible values of A? So A could be 1. A could be 2, A could be 3, and A could be 4. All of these belong to the set of natural number N. And here B has a fixed value equals to 4. Okay, so using this, we have to define our relation R. So R is the set of ordered pair. So if we choose A value to be equals to 1, then what is the value of B? B is fixed at 4. So we have 1 comma 4, that is one of the ordered pair. Then we can consider A to be equals to 2. 2 is a natural number less than 5, and B value that's going to stay fixed as 4. So we have the next ordered pair 3 comma 4 and the final ordered pair 4 comma 4. So this is going to be the relation R. Now that we have the relation R, we can easily define its domain and range. The domain of R, that's going to be the first element in each of the 4 ordered pairs. So we have 1, 2, 3 and 4. So 1 comma 2 comma 3 comma 4. The domain of R is the set containing the elements 1, 2, 3 and 4. Next, we defined the range of the relation R. So the range is simply going to be the second element in each of the ordered pair. Now the second element is simply B, that's 4. 4 is repeating 4 times, but we only have to mention it once since it's a set. So this is going to be the range of the relation R. Now let's go to the second problem. Now in the second problem, we have a relation S, which is the set of ordered pairs A comma B such that B equals to the absolute value of A minus 1. What is A here? That's given here that A belongs to the set of integers and it is such that the absolute value of A, it's always going to be less than or equals to 3. Okay, so here we have to be a little careful here. So it's given here that the absolute value of A is less than or equals to 3. This simply means that A is going to lie between -3 and +3. Fine. Now it's given here that A is an integer. So what are the possible values of A? So A could be -3, A could be -2, A could be -1, it could be 0, it could be 1, it could be 2 and 3. So there are 1, 2, 3, 4, 5, 6, 7 possible values of A such that its absolute value is less than or equals to 3 and all of them are integer values. Now using these values of A, we have to determine the values of B. So when we choose, so let's start with A equals to -3. So when we choose A equals to -3, then the corresponding B value that will be equals to the absolute value of -3 minus 1. So what is -3 minus 1? That's simply -4, but we are taking the absolute value of -4. So that's going to give us +4. So here we have the relation -3. If we choose A to be -3, then it will be related to the B value, corresponding B value, which is 4. Fine. So let us compute the value of B for each of the remaining values of A. So now we have the corresponding values of B as well. So let's now note down the relation S. So S is going to be the set of ordered pairs. So when we choose A value to be equals to -3, so remember A comes first, followed by B, the corresponding B value, which came out to be +4. So we have -3 comma 4, that is going to be one ordered pair. Followed by the next ordered pair, so we have -2. When A is -2, B value is 3. When we choose A to be -1, B value is 2. When we choose A to be equals to 0, B value is 1. When A value is 1, B value is 0. When A value is 2, B value is 1. And when A value is 3, then B value equals to 2. So this is going to be the relation S. Now that we have the relation F, we can define its domain as well as its range. The domain of the relation S, that's going to be the first element of each of the ordered pairs. So we have -3, -2, -1, 0, 1, 2 and +3. That's the domain, and that's also defined its range. The range of the relation S, that's going to be the second element in each of the ordered pairs. So we have 4, 3, 2, 1, 0. 1 and 2 are repeating. So we have 0, 1, 2, 3 and 4. These are going to be the range of the relation S.